The title is Interprocess Communication in Operating System. Here, the process within a system may be independent or cooperating. Cooperating process can affect or be affected by other process, including sharing data. Reason for cooperating process is information sharing, computation speed up, modularity, and convenience. Cooperating process needs interprocess communication. Two modules in interprocess communication are shared memory and message passing. Interprocess communication is a mechanism that allows processes to communicate with each other and synchronize their action. There are various methods of interprocess communication. Two of them are most common, being shared memory and message passing. What is shared memory? In shared memory, multiple processes are given access to a common memory space. This allows them to read and write to the same data, enabling fast communication since there is no need to copy data between processes. However, it also introduces a complexity in terms of synchronization to ensure that the concurrent access does not lead to race condition. Coming to the message passing involves sending data between processes through message passing can be done using system call provided by the operating system, such as pipes, message passing, and sockets, and so. Each process has its own memory space, and the data is explicitly sent and received via these messages. Look at this diagram, and the first one is a message passing, second one is a shared memory. Here, in shared memory, we have process A, and we have a shared memory, and we have a process B. The process A like to share a data to process B, then the process A have to share the data to the shared memory, and then from the shared memory, the process B will acquire the data. When the process B like to share the data to process A, the process B send the data to the shared memory, and then from the shared memory, the process A is going to acquire the data. This is what exactly the shared memory is. We have a common memory between both the processes or number of processes. We have a shared memory, and the data is going to share to the shared memory, and then the data is going to be sent to the required processes. Coming to the message passing, we have process A, process B, up to process N we have. And look at the bottom of the particular message passing, we have something called as a kernel, and above which we mentioned something like a queue, message queue that has M0, M1, M2, M3 up to Mn. So this M0, M1, M2, M3 up to Mn are nothing but the messages, and it should be in a queue. So if the process A likes to share the data to the process B, the process A should not send the data directly to the process B, and it doesn't have a shared memory here. And similarly, the process B, if likes to share a data to process A, it does not send the data directly to process A, and as well it doesn't have any shared memory. So these messages from process A and process B are going to share directly to the kernel and kernel operating system, kernel in operating system, and this messages will be passed to the required process A or a process B from the kernel. This is what exactly the message passing is. There is a kernel, the data is shared to the kernel in a message queue, and this message is shared wherever required. This is what exactly the message passing.